Hello, welcome to my channel. Another episode on the topic Coordinate Geometry 2, the grid circle. So in this episode, we will be dealing with equations of a normal or a tangent to a circle. And before we can find the equation of a tangent or a normal, we need to know the equation of the circle. Let's bear in mind that the equation of a circle is in form of what? A curve. So we will be having the x squared plus y squared plus x value, y value, and a constant. But to find the equation of a normal, we know the normal is a straight line. So we will be having our equation in this form. Our equation is going to be in this form, where the m is the gradient. So if the equation is going to be in this form, then we can also use the point slope equations, which is going to be y minus y1 equals to m x minus what? X1. We need a gradient, and we also need the 2 points. And the 2 points is the point P, which definitely will be given to us. Then for us to be able to find the gradient before we can find the equation of either the normal or the tangent, we need the point center. You know, if I find the value of the center, I can find the gradient as change in the y-axis over the change in the x-axis. So we can see I'm having 2 points. This point and this point, I can find my gradient. Then I can be able to substitute into this. Now, one property is that you can see the normal is a line that always passes through the center. The normal to a circle at any point always passes through the center. Or in a more refined way, we can say that the normal is just the extension of the radius. You can see from the center to the circumference, then we extend it, which is a straight line that passes through the circle. So in that case, the gradient of the radius is the same as the gradient of the normal. The normal and the gradient has the normal and the radius has the same word gradient. Okay, that is the first point. The second point is that the normal is always perpendicular to the tangent. Since we know a tangent is perpendicular to the radius, so if the radius and the normal are the same, then it means the normal is also perpendicular to the tangent, meaning at the point at which they meet, it always forming a right angle. And the properties of perpendicular lines is that the product of their gradient must give us a negative one, or the gradient of one is a negative reciprocal of the other. So what we mean is that if we represent mr as the gradient of the radius, which is also the same as the gradient of the normal, then using mt to represent the gradient of the tangent, that will give us the negative reciprocal of any of this gradient of the radius, which is the same as negative reciprocal of gradient of what? The normal. But as I said earlier on, that we can also say it is the product of their gradient must give us what? A negative one. So you can see, if I multiply these two, which is going to be this times what? The itself, that is gradient of t times gradient of r, so give us what? A negative one. What is the gradient of t? Which is going to be negative 1 over mr. Then what is this? The gradient of this is going to be just mr. Don't forget, the gradient of tangent is this. So I put it there. What is the gradient of the radius, which is still mr? So if I multiply the two, my answer should be a negative one. So either you multiply the two gradients to get a negative one and make one the subject, or just have one, which is the tangent, being the negative reciprocal of believe this point is clear. These are the two main points we are going to be holding key to our calculation. The gradient of a normal and that of the radius are the same. So the moment I know the gradient of the radius, then I know the gradient of the normal. Then I can substitute that gradient and the point P into a point slope formula. Then I can get the equation of that straight line. You know, it's a straight line. Good. If I also need the equation of the tangent, which is perpendicular to either the normal or the radius, it is going to be the gradient of the tangent is a negative reciprocal of either the normal or the radius or the normal. After getting that gradient, using the point P, substitute back into the same point slope form, then the equation of that straight line is also derived. I believe the concept we are trying to drive home is clear. Let's pick a question and see how we can employ that. Okay, so the equation of a circle is given as x squared plus y squared minus x, 8x plus 4y, which is equals to 0. We have to find the equation of the normal and the tangent at the point 6 and 2. So you can see that the point at which the normal and the tangent touch the circle is given to us. But the gradient that we need to use to find the equation is not given. So we can use the equation of the circle to find that gradient. What do we need? We need the center. We know the center in the P is what we are going to use. So we need the center. So comparing this to either the standard form or to the general equation, we can be able to find the center. Let me use the standard form first. We know the standard form is x minus a squared plus y minus b squared equals what? R squared. This is the standard form of an equation of a circle. For me to be able to send this into this form, I need to do completing the squares of the x and the y separately. So if I want to rewrite this, I'll be writing x squared minus 8 plus y squared plus 4y equals 0. So pay attention to this. In completing the square, what do? We find half the squares of what? The coefficient of x, and half of this is going to be negative 4, the square of that. We add it to the left and the right. So since we don't want to send it to the right, it means I'll be adding and be subtracting it from the left, meaning I'll be having x minus 4 all squared, then minus the square of negative 4, which will be 16. Then I'll perform the same here. Half the square of the half of 4 is 2, the square of that. So that becomes plus y plus 2 all squared. Then I'll be subtracting the square of 2, which is going to be what? 4. So minus 4 equals 0. So bringing these two together, x minus 4 all squared, y plus 2 all squared. Don't forget, this is going to be negative 20. So negative 20 crossing becomes what? A positive 20. From here, the center is going to be this, which is the a minus 4. So I have 4 minus b positive 2. So minus will affect this to make it what? A negative 2. So now the center is known. Since I know the center, I know the point, I can find the gradient. I don't need to find the gradient of the normal, of the radius, but of the normal, since they are the same. So gradient of the normal, which we know y2, y1, x2, x1. Picking this as my x1, y1, x2, y2, I'll be having a negative 2 in this case, minus what? 2. over a 4 minus what? A 6. And that will give us negative 4 over negative 2 equals to positive 2. So the gradient is known using the point-solution form with the point 6, 2 and the gradient. Our equation of the normal is going to be y minus y1, in this case is going to be 2 equals to 2x minus x1 going to be what? 6, right? Let's expand here. Y minus 2 equals to 2x, 2, 6, 12. Leaving our equation in the equation of a straight line form, not the standard form, we can send the 2 away by adding 2 to both sides. Y will be equal to 2x minus 12 plus 2. And I believe this will give us negative 10. So y will be 2x minus what? 10. So the equation of the normal will be y equals to 2x minus 10, where the gradient is going to be 2, y-intercept will be negative 10. Good. Now, we are also going to find the equation of the tangent. What is going to be? We know we need the gradient. So, gradient of tangent is going to be the negative reciprocal of the gradient of what? The normal, going to be what? 2. So using this as a gradient, using the same point, substituting it into our point-solution form, we are going to have y minus y1 going to still be 2 equals to negative 1 over 2x minus 6. We are only changing the 2 we have here with our gradient. And because we are having a fraction, we need to multiply through by the LCM, which will be 2, 2, 2 throughout. So 2 times this will give you 2y, 2 times this 4, 2 times this will be negative 1, and negative 1 times x will be negative x, negative 1 times negative 6 will be plus what? 6. So what do I do here? If I send this there, I should be able to divide by what? The 2 in order to make my y in this form. So because of the 2, I can write this equation in the standard form, as in transporting all this in here. So the x become a positive x plus 2y minus 4 minus what? 6. And we know minus 4 minus 6 will be what? Minus 10. So we have minus 10 equals what? 0. So this simply means that the equation of the tangent to this circle will also be x plus 2y minus 10 equals what? 0. This in the standard form. If you want to make the y the subject, it means this is going to be plus 10, then we divide 2. We divide through by what? 2. You have your half here, then you have your 5 there if you divide by the 2. But I just want to leave this one in the standard form and this one in the equation of the straight line form. So you can see the concept that we need is how we can find the center from the equation of the circle. Then when you get the center, then you can use the center and the points on the circle to find the gradient. The gradient of that radius is the same as that of the normal. The gradient of the tangent is a negative reciprocal of the normal. I believe this will not be any problem. The points are clear. You can capture these properties or principles when they come to normal and what? Tangent. Thank you so much for watching. Don't forget to share this video with somebody who might need this. Anybody who you know is a student somewhere. Give them this video. Encourage them to subscribe to the channel. Subscribe if you are new. Leave a comment for us to get interactive. And like the video and share. Bye-bye.